Okay, in this problem we are going to solve for the acceleration of the sliding block. This block is sliding down with a ramp at this angle and this coefficient of friction, and we want to find the acceleration of the object. So first you select the x and y axis. Is convenient to select it like this, and then you have gravity down, normal force, and friction. And this is the reason why you put the axis in this direction, because the block does not move in the y-axis. The block does not move in the y-axis. So from geometry, you know that this angle is this angle. So this piece over here is adjacent to the angle, so it's mg cosine of the angle, and this piece over here is mg sine of the angle. So now we are going to do the x and y axis. So in the x axis we have negative friction, positive mg sine of the angle, mass time acceleration. In the y axis we have normal force, positive, minus mg cosine of the angle, mass times acceleration in the y-axis. And this is the one that is 0 because the choice of the axis being in this direction. The other problem what we could see is that we could put the axis like this. We put the axis like that. The problem is mathematically complicated. But if you put the axis in this direction, the acceleration in the y-axis is always 0. So this equation that I'm going to call 2 is n minus mg cosine of the angle equals 0. And over here we got friction plus mg sine of the angle equals mass times acceleration. From here we know that the magnitude of the normal force is mg cosine of the angle. And we know this empirical equation. This is an empirical equation that connects the friction that is along the horizontal axis of the surface with the normal force that is because the block is not penetrating into the wedge. So we put these two equations into number 1. Let me put over here with more space. And this is equation 1, and this is equation 3. And now let me just write them over here. Okay, from these two we get that Fk is mu mg cosine of the angle. Okay, I substitute n into the number 3. And from these two, I substitute Fk into number 1. I get the mass disappears from the equation, so the acceleration is independent of the mass of the block. and the acceleration of the object is the acceleration without friction, that is the gravitational component in the x-axis. So if this is the acceleration of gravity, let's put it like this. This component here is g. No, it's this angle over here. So this component here is opposite to the angle. But you have less acceleration because of the friction cosine of the angle. So this is, if you take g as a common factor, so this is the acceleration of the object. This is the magnitude of the acceleration of the block down the ramp. Now, if you do a lab, we could put a motion detector behind the block over here and measure this acceleration, and we could change the angle. Okay. The problem is that we have sine and cosine over here. So how to use this equation in a lab scenario? So you put a motion detector over here, and you measure velocity versus time with the motion detector. Supposed to get a straight line, and the slope is the acceleration. And you change the angle of the ramp. So how to modify this equation? But remember, in the lab, in the problem, the unknown is the acceleration. In the lab or experiment, the unknown are the physical constant, that is, in this case are g and mu k. So how do you find the acceleration of gravity and mu k? And you measure A, the acceleration, by putting the motion detector behind the block, and the angle, you can vary the angle of the ramp. So by measuring velocity versus time with the motion detector, you get the acceleration, and you just modify this equation. You divide by sine of the angle, and the y-axis, you are going to plot the y-axis, you are going to plot acceleration over sine of the angle, and on the horizontal axis you are going to put tangent of the angle, and the y-intercept is going to be g. The y-intercept is going to be g. This has negative slope, so these are going to be your data points, and the slope is going to be negative mu k, the coefficient of kinetic friction, and the y-intercept I'm sorry, this is mu k, so it's mu g. Mu k times g is the slope, and the y-intercept is going to be g. Okay, so when you use the software for the best fitting line, the y-intercept is going to be the acceleration of gravity, and then mu k, so the unknowns are going to be g, is the acceleration of gravity is the y-intercept, and mu k is going to be negative the slope divided by the y-intercept. And that's how experimentally, this is how how you determine the coefficient of kinetic friction when the block is sliding down the ramp.